What are the polar coordinates of a point? Let us start with the point M of Cartesian coordinates x and y. X being the abscissa and y the ordinate of point M, then x is pointed on the horizontal axis and y on the vertical axis. Then we reflect parallel to the axes to plot point M. However, to plot point M on the exact same position, we first need the distance between O and M, denoted here by R, and the angle OM forms with the horizontal axis, which we denote here by theta. R and theta are in fact the polar coordinates of point M. Now, zooming in on that triangle, note that x, the abscissa of point M, gives the length of the horizontal leg of the right triangle, and y, the ordinate of M, gives the length of the vertical leg of the right triangle, which gives the impression that the Cartesian and polar coordinates are linked, and we could use one to convert to the other one. For example here, cosine theta is by definition the ratio of the adjacent side to theta, which is x here, and the hypotenuse, which is r here. Similarly, sine theta is the ratio of the opposite side y and the hypotenuse r. Solving for x and y, we obtain x equals to r cosine theta and y equals to r sine theta, which are the formulas used to convert from polar to Cartesian coordinates. Now, what if I wish to convert from Cartesian to polar coordinates? According to Pythagoras' theorem, we know that r squared is equals to x squared plus y squared, which leads to r equals to the square root of x squared plus y squared. On the other hand, tan theta is the opposite side y divided by the adjacent side x. Both these formulas are in fact used to convert from Cartesian to polar coordinates. In this example here, I'm given a point M with polar coordinates square root of 2 and 3 pi over 4. To find the Cartesian coordinates, I use the conversion formulas from polar to Cartesian using r equals to square root of 2 and theta equals to 3 pi over 4. So x would in fact be square root of 2 cosine 3 pi over 4, and cosine 3 pi over 4 is negative square root 2 over 2. Multiplying that by square root 2 gives me x equals to negative 1. Similarly, y would be square root of 2 sine 3 pi over 4, and sine 3 pi over 4 is square root 2 over 2. Multiplying that by square root 2 gives me y equals to 1. So negative 1 and 1 are the Cartesian coordinates of point M. In this other example, I am given a point M with Cartesian coordinates 1 for x and negative square root 3 for y. To find the polar coordinates of M, I use the conversion formulas from Cartesian to polar. Using x equals to 1 and y equals to negative square root 3, I first find r equals to the square root of 1 squared plus negative square root 3 squared, which is in fact the square root of 1 plus 3 equals to square root of 4, which leads me to r equals to 2. On the other hand, tan theta being y over x, replacing y by negative square root 3 and x by 1, I end up with tan theta equals to negative square root 3. However, in my table of remarkable angles, I know that tan of pi over 3 is equals to positive square root 3, and pi over 3 being in quadrant 1. However, point M has a positive x and a negative y, so theta corresponding to this exact point M is located in the fourth quadrant. So if the angle is pi over 3 in the first quadrant, then in the fourth quadrant it would be negative pi over 3. Then in that case, theta is negative pi over 3 modulo 2 pi, which leaves me with M having as polar coordinates 2 and negative pi over 3.